Hi, I'm Roberto and I'm going to teach you physics. I don't know how to going to merge these videos because they are in a different memory card. So anyway, I managed to do it. I don't know if you can see. Yes, you can. So we were analyzing the different fluids, the different, let me close it. Analyzing the different fluids according to its behavior, to their behavior in viscosity. Okay. Analyze the Newtonian, the shear thinning, the shear thickening. You know, Newtonian viscosity doesn't change with agitation. Shear thinning, viscosity decreases with agitation. Shear thickening, viscosity increases with agitation. And then two types. Well, we have to study two types more. Okay, two types are left. I think you say that are left. Yeah, I don't know. Bingham plastic. So an example is ketchup. Okay, I want to tell you the story, but I ran out of memory. So there were two teenage couple, boy and a girl, and the boy wanted to do something, right? To have something. And the girl said, come on, I don't want to. You know what I'm talking about, right? So I don't want to, and the boy says, come on, at least touch me, right? The boy says. And the guy says, I don't know how to do it. And the boy says, come on, like a bottle of ketchup, you know, and the girl's that. Yes, so this is our example of Bingham plastic, like ketchup. They need an initial force to start moving. Okay, initial force to start flowing. Okay, flowing. Yeah, you see, viscosity is higher at the beginning, and then once they overcome this threshold, okay, they behave like Newtonian. Viscosity doesn't change with agitation. Then next, they behave like Newtonian. Okay. There are other examples. Toothpaste. Okay, ketchup, toothpaste is the same. Toothpaste. So to get my toothpaste out, here instead of a tube we use small bottles. Okay, they are becoming more and more common in Spain. So I shake the bottle and then it flows. Toothpaste. Another example is a classical one. It's called beaten egg whites. Beaten egg whites. Egg whites. In Spanish, egg whites. The equivalent is like it's kind of something like called snow point egg whites. Yeah, because these resemble, they seem like snow. Have you seen that one test if you beat an egg white? Okay, is to in a bowl is to slowly turn the bowl, okay, and it doesn't have to fall. And sometimes you have fun because putting it upside down and it's not moving. At some point they start moving because when the force is strong enough to overcome this initial point, then they flow. Okay, Bingham plastic. And the last type is called non-Bingham plastic. So very simple. Non-Bingham plastic. 5 is the 4, and the 5 is non-Bingham. non-Bingham plastic. There are other types, and where the effect depends on time. They're called thixotropic and rheopectic, but yeah, they're too advanced, and I don't know much about them. I must confess. So I also want to include them. So this non-Bingham plastic is very similar. So it has they have to overcome high viscosity. So and there is, as before, there's an initial force. It's not very well drawn, but it follows, and then okay, a big step, and then next they behave like shear thinning. Next, shear thinning. Viscosity decreases with agitation. Thinning. Yes. An example, a classic example, I'll give you more later, but it's hot chocolate. Okay? Hot chocolate. Hot chocolate. It's widely used in the food industry, Imagine how many millions of euros are in hot chocolate, We every day hundreds of thousands of tons of chocolate are eaten every day, In some preparation, all of the preparations have been warm before, okay? So non-Bingham plastic. So in the previous class we talked about the study of viscosity versus shear velocity. This is called rheogram. Rheogram is a portmanteau. I think it's called portmanteau. Not sure. Rheogram is a rheological diagram. So it's a short for rheological diagram. And there's another one, very important, which is, this is our 5, okay? And then this first rheogram is ready, viscosity versus gamma dot. It tells us the behavior of viscosity, okay? You see, depending on the force, the force you apply to the fluid, how viscosity behaves, okay? Viscosity behavior. And there's another rheogram. Okay? Call this rheogram 1 if you like, but that doesn't matter. Rheogram 1. There's another one, another rheogram. I didn't find the black pen, so Pennarello Lavagna, it says, because it's in Italian. Okay? Whiteboard marker. I didn't find the marker, the black marker. So that's why I turned into blue. So another rheogram called the rheogram 2, which is the shear stress versus shear velocity. Why is this important? Remember that the Newton's law we studied, with the experiment of the soap, how you remember, with the Porrex pan and the surf tables,